over. And this is a key, this is a key, and the project, we have the project name and the project ID number. This one has a single location. Okay, and also the dependent, we have the name and relationship. I'm not sure whether we have the relationship, so on and so on. Okay, I do not put all the attributes here. Then the next thing is, so for example, this is a key, this is a key. Unfortunately, there's no key on the dependent given the information. The third one is a relationship. For the relationship, we can use this one and connect it to the entity, for example, manager. And we have the starting date. Starting date can be part of this one or here. So, and works for, and this is a control, and this is the head, and also we have the recursive, so supervisor. Then works on. If you have attribute like the hours, we can even this one relationship has the what? It's the attribute. Okay, then for the relationship we identify the attribute, and for the relationship there are two things we need to identify. One is type of relationship, which means cardinality. One to one, one to many, many to many. So for example, manager is one to one. How many manager? One manager per department. How many departments do you manage? One department per the supervisor, the manager. One to one. However, the department and employee is one department has many the employee. Okay, one to many. And one employee has many dependent. And one department control many. It's clearly mentioned in the description. Who decide that? You decide based on what? Requirement, not based on your experience or knowledge. If you have ambiguous thing, discuss with your customer. Then if your customer may not answer, then at that time, considering the functional, the analysis, the database requirement, and other thing you can decide. Okay, this one is many to many. Then next thing is whether total, full, or partial. For example, each department should have the manager. However, not always employee manage the department. It's optional, single line, mandatory, the double line. Okay, and each project should have the controlling department and dependent also. So you can decide the single line, double line based on the total or partial participant. Then I think what we miss the weak entity. In case of weak entity like this one, we do not dependent does not have the key. In case the same name, common name of the dependent of the employee, at the time we can identify dependent with the help of employee, right? So if we know the employee SSN plus name, you may not make the name same as your another child, right? So among the children, the same sibling, we will not have the same name. So using this information, we can identify. At that time, this weak entity and the identifying relationship will be double. Weak entity is a double rectangle, and identifying relationship double diamond, and connect double line. Because you must have this one. And also, this name will be used for partial key, part of the key, double, and not double, dot line. And this was the homework for your practice, the handwriting. If you already did, submit, okay, over here. Okay, so this is the same as this one. Any question before we move to the next? Practice. I believe because you are so smart and so intelligence enough so you can understand from my lecture. That doesn't mean you are able to do the conceptual modeling. Definitely not. So conceptual modeling especially need experience, okay, practice, and also domain knowledge, okay, not computer science knowledge. So please practice by yourself. You can find, I'm going to upload the sample, the database requirement, and with the ER diagram. That has been done by in my previous semester. So I actually sometimes add the homework, make the requirement, one-page requirement with the question. Then that can be used for midterm. So I don't have to make the question. I recycle such a thing. I'm going to share the previous semester, the homework regarding to the ER diagram. You can practice. Then I'm going to use that for the midterm exam. Okay. Then we already did the weak entity, the attribute, and so on. So this is the final output of the what? The company database ER diagram. You are going to create the same ER diagram using the Irwin software. Irwin software is one of the modeling tools. Why have to use? No, it's just one of the tools. Like when you edit the file, you can use the Microsoft Word, you can use the Notepad, WordPad, whatever. Okay, same thing. However, Irwin is one of the most popular database modeling tool. Not only for the database modeling, it can be used for general project management also. Also for the database, actually Irwin software, you are able to connect to the database. So for example, if you create the entity, automatically create database table, even though you do not know how to create. This kind of software is connected. Also, vice versa, if you connect the existing database, ER diagram will be automatically created, which is called reverse engineering. Actually, one time I did a project implementing reverse engineering software. It was horrible. Really. So because you should know the catalog database, you should know the database program, you should know the programming itself to draw the diagram. So it was really the hardest project ever I offered. So one time I did, then after that I didn't. But if I have the additional special section, it's very fun actually to do. So you learn even the programming, database programming, and the catalog database administrative job. It's much fun to build such a reverse engineering. Okay. Then there's another. This is one of the notation that we are using. This one. Okay, especially this textbook. There's no standard. So we can use a UML diagram. Later we will see the UML diagram like this one. Exactly same meaning. You can use this UML diagram or any other notation like the crop notation or industrial notation. There are a bunch of different notation, but most of the time you are able to understand the difference. There's no difference, only the notation. Then this is another way to represent this cardinality. We learned only one-to-one, one-to-many, many-to-many. However, when we create the database, this is not. Please don't spend your time to do your homework. So after I think you'd better do your homework during the exercise lab. Okay, so we have the exercise lab. So please pay attention to this lecture. Okay, so especially the cardinality is not the detail enough to create the database later. So somebody likes this notation which is called the min-max notation. For example, so in this case, what is the cardinality between employee and department? One to many. And this is the mandatory, this is the mandatory, which means at least one employee per department. That's it. But if the customer asks, at least each department should have 4 employees. The manager, vice manager, and 2 other employees. That's a requirement. Is there any way to represent such a requirement? No. So at that time, using this one, 1 means option, N means many. That's it. So to represent, not 4 to n. So to address that one, we have the min-max notation. What is the minimum participation? What is the maximal participation? For example, in this case, don't be confused. One to many. One department, many employee. Many to one. Okay. However, in min-max notation, you can understand only this like that. So how many manager? Minimum 1. Maximum 1 per department. In this side, employee manage how many department? Minimum 0. Sometimes you are not manager. Maximum how many? So in case you are manager, only 1. So that is the min-max notation. More precise. But many of the students confused. This one is just understand as it is. Then sometimes confused with this one. This is many employee works for one department. Even I confused a lot. So I actually memorize one case. Then it will be clear the other cases. One more thing. This one is a min-max notation. Works for one employee. For each employee, how many department? Minimum 1 department. Maximum 1 department. For department, how many employees? Okay? 1 employee. Minimum, in this case, 1 employee, and maximum n number of, no limitation. Okay? So then, in this case, there is for example, if minimum is 4, we can change it. 1 replaced by the 4. Minimum 4, maximum n. What about this one? Dependent. For the employee side, how many dependent? Minimum 0, which means you are single. Okay? Maximum unlimited. If you are super rich, you can adapt. Right? Then, what about the dependent side? If you are a dependent of employee, how many your parent? Only 1. At least 1. Otherwise, you cannot be dependent of that Google company. Then, maximum how many? Parent? 1. So 1, 1. So then we can represent more precise the requirement using min-max notation. In our project, either way is fine. For the midterm exam, either way is fine. It's based on your preference. Yes?
We have there 4 to n.
Yes.
How it's counted? 4 to n.
To your customer. For example, in case your customer asks minimum 4 employees per department, so we cannot represent that requirement with this notation. At that time, we need to use this min-max notation. Okay? Any question for the min-max notation? But don't be confused. It's confused a lot. So idea is simple. So this is another notation. Then another thing is, so far we have talked about relationship between how many entities? 2. If somebody may argue, this one has only 1 entity. No, this one has also 2 entities. Even though pointing the same entity, it's like the employee and another employee and supervisor. It's a supervisor. This one supervising side. Okay? It's a still binary relationship. So all of this are binary relationship. However, in real life, so there might be relationship with the 3, 4 relationship, which is called n-ary relationship. So I didn't see the 4 entity relationship, but the 3, which is called the ternary relationship, is possible. For example, this one is the relationship supply relationship. Supplier supply a part to the project. Okay, not just the supplier, supply the project for specific. So 3 entities are involved here. Okay. However, another example is like is in the semester, offered in this semester. For what? Course. So instructor offer course, which means we don't know when. But instructor offer semester, which means instructor is available this semester. Which course? What? The course will be offered in this semester. Who? So by combining all of this, instructor offered something course to the in this semester, in certain semester. This is a ternary relationship. Okay? Problem? There's no problem in the modeling. However, it will be problem in later database modeling. Database cannot handle such a ternary relationship, only binary relationship. So as I said, computer is not that smart, only binary, 0 or 1. Binary is good enough. To address that one, sometimes you can use such a several binary relationship, like the supplier can supply part, or supplier supplies to the project, what part is available for the project. You can separate. You can use the binary relationship. Or another option is you can create entity for the supply. Then somebody may suggest the last time many-to-many relationship. We can create the in-between entity, then connect the binary relation. Same idea. So we can create the supply, then supplier, supply. The supply will be to the specific project. Supply for the specific part. So we can create a ternary relationship. This one is usually weaker entity because it's new created by combining S name, key, key, key. By combining all three key, we can create the strong key. That is the another option. Yes?
Can attributes of relation type can be considered as a ternary relationship?
Which means quantity.
Yeah.
So quantity, this time where it goes. This will be the quantity will be the attribute of supply. So it's missing. And quantity is here. So I think the missing. Question. Are they equivalent? One. Same one. So A, B, C are the same or different? If they are the same, I will not be asking. Right? They are different. Okay? For example, you can supply the part 1, part 2, part 3. Okay? But this part will be used for the project. That doesn't mean supplier supply to the project. Okay? This is this relationship, this relationship, this relationship. Also, this is the same meaning. There is this relationship between this, between this, between this. That doesn't mean this is the supplier is available for the specific project for specific part. But this is more generous. You can have additional part here. You can have the additional information here. So it's not the same as this one. You may have additional information in this, the flexible. Okay? Which means you need to manage the data later, separately. So this is the one drawback. But no way to create the relationship in the database later with the three entities. Okay? Another example is this one. Okay? Instructor can offer this and blah blah blah. So that is a ternary relation. Later we will see when do you remember? We have information, then data base. Then we are doing step by step. The next step will be we convert the ER diagram to the database modeling diagram. At that time, we will discuss a little bit more about the ternary relationship. Keep in mind. Okay, so another example is a university database. If you see the handout, there is this one. I don't expect you read all the detail, but at least from this diagram, you should be able to understand. Okay, meaning of this database. in other words, requirement of this database from the diagram. Okay, so this is a little bit shorter version. Then, for the modeling, we can use the tool software. There are a bunch of different tools from the ER, the Alwyn, then some of them, like the rational rules and this kind of thing, are very expensive one. So it's not only for the data or database modeling, it can be project management tool nowadays, and also component based. So if you design such a thing, automatically create code, okay, component. They automatically create the code. What you need to do is only add the business algorithm inside, okay. So because of that, the project manager manages a huge project by designing entire project using this tool and assign to this team and this team or individual. You can just focus. You don't know the big picture of the project, but you can just focus on input and output of each component created by the project tool or the conceptual designing tool. Okay, that will be kind of component-based project management. So today we are going to use the Alwyn software, which is one of the most popular one. Okay, if you do not download and install yet, please do so. Then Shulai will continue the project.
Oh, so it doesn't work on Mac.
What does it mean, Mac?
Mac.
MacBook. I didn't test it. So because of that, you don't have to use only the Alwyn for your project. The last one, the Visio. So I personally, for small project, I personally like to use the Visio. But the big project, definitely you need to. Nadia, so Nadia, one more thing for you to do. Then, so one more thing, the 10 more minutes. So let's go back to your 3 years old and 4 years old. So do you remember when you were 3 years old, 4 years old? Huh? Some of them. In my case, the oldest memory is in my kindergarten. But before that, probably when you are 3 years old, 4 years old, your mom, the taught a lot. Like this is the laptop, probably not at the time. So this is an apple. This is something to eat. This is dangerous and teach it. Okay. For example, when you learn the apple, how did you know? This is an apple. This is a banana. Banana. How do you know that? Someone taught. Your mom taught. So or the TV. Nowadays, YouTube teach it, all children. So this is an apple. This is an apple. This is an apple. Then in your mind, eventually, you have the concept or definition of the apple in your brain, right? Even though that's not like the dictionary, in the brain, the neuron somewhere, your part of the brain, neuron, so rounding and shiny and mostly red color, but sometimes bluish, so it is an apple, okay? It's delicious, but sometimes not, so you have such a definition. Then, later, when you see the new apple, have you ever seen this apple before? No, but you know, this is an apple, I can eat, even I can pay for that apple. How do you believe? Whether there's poisonous or not. But based on your experience and your definition, this is an apple, even though you never seen this an object before. So this is how we learn, how the people, the train, like from an object. Think about the object-oriented concept. When you design the class, how you define the class? From the collection of real-life objects. So you find the common thing and define the variable, define the operation method, then make the class. Using class, you can create an object in the memory, instantiation using new in Java. Same thing, when we learn something, from the individual thing, we can generalize to the definition of the apple. So then, once you have the knowledge on apple, you can use that knowledge This is an apple, this is a good apple, this is a bad one, something like that. You can specialize. So this is called, from each of them, you can generalize apple. This is called generalization. Once you have generalized concept, you can what? Specialize. So specialization, generalization is the two main process to manage the knowledge. Okay? It's very important actually. It's used for a lot of the computer science concept, like the object-oriented concept. Also nowadays machine learning use such a training. Machine learning and data mining. If you are taking the data mining, I probably mentioned about this kind of training process. Then test. So this is the generalization, specialization. We try to use such a thing. So in our real life, we have a lot of such a thing. Like from the entity, we can generalize. Sometimes different types of employee we have. Okay? That's not, for example, we have the employee. But we have a part-time employee. We have the full-time employee. For example of the generalization is your customer give the one batch of the full-time employee information. Another batch of the file is a part-time employee information. When you design analyze this data, you realize that this is the employee and this is the employee. Then you are able to generalize the employee to this one. Or vice versa. So your employee gave to you one big file of employee. Then you realize that half of them part-time, half of them full-time. So you can specialize. This is an employee, this is an employee, this is also employee. Using ER modeling, no way to represent such idea. I know, in terms of object-oriented concept, it's very easy. You can define superclass, inherit, subclasses. However, ER modeling is not the UML modeling, object-oriented concept. So, no way to represent. To address that problem, we are going to extend plus something that represent generalization and specialization. That is called extended the ER model or enhanced ER modeling that include the generalization and specialization. Let me use a slide to a little bit speed up. For example, here we have employee. For example, specialization. I realize that there are different types of employee. Like the secretary is employee, and technician is also employee. Engineer is employee, like this. Okay? All of them are employed, but we don't want to create a separate employee. So how can we represent? So we are going to use the super and subclass relationship. Super and subclass relationship that you learn in your object-oriented concept. So in this case, this is a superclass, super entity, the for employee. Then these are the subclasses, sub-entity of employee, secretary, technician, and engineer. At that time, we are going to follow the same concept you learned in the object-oriented concept, kind of inheritance, for example. So all these attributes of the superclass inherit to the subclass, but we will not manage it separately altogether because it's so common. We don't want redundant information. It's waste of. Same thing, inheritance. When you create the subclass with the superclass, it's automatically inherited. You don't have to define again unless you override. So that is the superclass and subclass. Plus, subclass can have their own attribute. Like the secretary has a typing speed, technician has T grade, engineer has engineering type. Okay? Then he can secretary has the key or not? There is what is inherited from employee. SSN is the key. Technician, SSN is the key. Engineer, SSN is the key. At that time, this is the super and subclasses of the employee. Question: how many entities do we have here? It's one entity. Then we specialize or generalize. At that time, if we build this one from subclass, first identify secretary, technician, and engineer, then come up with the employee. This is called generalization. Like at that time we can use this symbol, direction, curve. Okay. On the other hand, if you identify the employee first, then specialize, like the top to bottom, we can use the curve. However, in terms of database, it's not very important. Okay, no way to represent generalization process or specialization process. But for your better understanding, you can use such a thing. Couple of more things. So then, sometimes there are two characteristics of the super and subclass. Sometimes, so full-time and part-time. Is there anyone who is full-time plus part-time? Either full-time or part-time. At that time is disjoint. So we can represent the characteristic of the relationship, super and sub T. However, if you allow full-time and part-time, it's called overlap. So there are two types, disjoint or overlap. So we can use E or O or D to represent such a relationship. So there's an example of the overlap. Yes. So vehicle, either car or truck. There might be vehicle. It's a car and plus the truck. Okay. So at that time we can use the D. It's the disjoint. Either this is disjoint. Overlap. There's an example of overlap. Oh yes, part. So this is good example. Part is a manufactured part, purchased part. You purchase the part, but it's manufactured, not homemade. Okay, at the time both of them, the certain part belongs to this one and this one. At the time you can represent O, overlap. One more thing is participation. So double line means always what? Mandatory, which means the part, any part should be at least one of this. Okay, that's the full participation. However, sometimes like this one, there might be employee who are not secretary, who are not technician, who are not engineer. At the time, single line. Also, one more thing, always when you identify super and subclass, so first, which one will be superclass, which will be subclasses. Then, whether disjoint or overlap, whether full or partial participation.